All right, so lesson 4.3, I'm not going to do all of them like usual. I'm just gonna give you the overview. I'm gonna start with number 6. Actually, I'm gonna do 6, 7, 9, and 12 on the first page. So this lesson, the first part is adding and subtracting radicals. So if you look at number 6, I can only add or subtract the -2 and the 3 if I have the same number under the radical, which I do. So I'm going to go ahead and do -3 plus 2, which is -1, and then my radical just stays the same. And I really don't need that 1 there. I could also write it like this. So that's all I have to do for that one. I just combine like terms if my radical is the same. Number 7, I can't add the 5 and the 2 yet because the 20 and the 45 are different. So I'm going to have to simplify each of those first. So I'm going to start with 2 and 10, and you can use any numbers that you want. They're going to end up with the same numbers anyway. And then 2 and 5. And then 45, I'm going to use 5 and 9. And then 9 is 3 and 3. Okay, so since I don't have a root index, there's really a 2 there for each, which means I need 2 of the same number. So I got 2 2s here, and then over here I have 2 3s. Now, as of now, these are separate. So I'm looking for a pair, which I already circled. So I have a pair of 2s right here. I'm going to take out the 2 and put it in front with the 5. Therefore, I have 10 so far. And I have a 5 all by itself, so that's going to stay underneath. Over here I have a pair of 3s. I'm going to bring those out and put it with the 2 that's in front. That's going to give me a 6, because again I want to multiply. And then I'm also left with a 5 underneath. Since these are now the same, I can go ahead and add the numbers in front. It's like you're combining like terms. So my answer is 16 square root of 5. Okay, moving on to number 9. On this one, or on any of these, you have to first of all look to see if you're going to bring out a negative or you're going to bring out an I, and it depends on the root index. So these both don't have a root index, so really there's a 2 there. So since the root index is even, I'm going to bring out an I. So I'm going to change this to 4i square root of 12, and this one's going to become 2i square root of 27. So I can't add because the 12 and the 27 are not alike. You have to have like terms, and in this case, the radicals serve as a like term. So I'm going to have to break those down. So I'm going to use 2 and 6 for 12. And then I'm going to use 2 and 3 for 6. Okay, it looks like I have a pair of 2s. So I'm looking for a pair. So I'm going to bring those 2s out and put it in front with the 4i. So this will give me 8i. And then I have a 3 all by itself underneath. Okay, 27, I need to squeeze this in here. Let's see, I'll do it this way. So 27, that's 3 and 9. 9 is 3 and 3. And again, I need a pair because my root index is 2. So I got 2 3s. I'm going to bring out that group of 3. I'm going to multiply it by the 2i. That's going to give me 6i. And then I have this 3 left underneath. Okay, so it looks like I now have like terms. So I'm going to add the 8 and the 6 together, which is 14. And then my like term would be I square root of 3. So that is my answer to 9. Okay, number 12. On this one I have a negative underneath. However, since this is odd, I'm going to take out a negative. Okay, so now I'm going to simplify because I can't subtract if these are different, which they are. So 81, that's going to be 9 and 9. Those both break down to a pair of 3s. I need 3 of the same number, which I have. And this 3 is going to stay by itself. So I'm going to bring out this group of 3. I'm going to put it in front with the negative. So that becomes -3. I have a 3 left under my radical. Don't forget the root index, so really it's the cube root of 3. I can't simplify this 3, so this is just going to stay the same, so I'm just going to bring that down. And then from here, I can only combine if I have like terms, which I do. They both have a cube root of 3. So from here, I'm going to take -3 minus 3, which is -6. And then I bring down the cube root of 3. So that is my answer to number 12. All right, so that's the first page, adding and subtracting radicals. Okay, it looks like the next page is similar, except I have some that have 3 with them. You would just do it the same way. I'm going to actually do 18. Because 18, I have variables and I have numbers underneath. So let's take a look at 18. So I would be able to add if it was just a y squared underneath. However, I also have numbers, and since they're different, I can't add yet. So I'm going to have to break those both down. So 45 is 5 and 9. 9 is 3 and 3. Okay, I'm going to go ahead and just take care of this one first. So my root index is 2 because I don't see anything there. So I'm going to take out a group of 3, multiply it by the 6 that's already out there. It's going to give me 18. And I have a 5 underneath. And I also have a y squared that I haven't done anything with yet. Okay, and I'm going to break down the 20. That's going to be 5 and 4. And 4 is 2 and 2. Okay, I need a pair as well because I don't have a root index. There's really a 2 there. I got 2 2s. That's one group that I'm going to bring out with the 4. Multiply that together. I get 8. I got a 5 left underneath, and I also have a y squared. All right, now I have like terms. They both have a 5y squared underneath. So I'm going to go ahead and add the 18 and the 8 together, which is 26. And then that just stays the same. Now, as I'm looking, this isn't actually my final answer because there's actually something I can do now with my variables. There's really a 2 there. So what I want to do, if I have a variable with an exponent, I'm going to divide them. So 2 goes into 2 exactly 1 time. So I'm actually going to bring a y out with the 26, but the 5 stays underneath. So that is actually the answer I want for this one. Okay, so now that's adding and subtracting radicals. We're going to switch now to exponent rules, which you've done before. Let's talk about the rules first. So x to the first, that's just x. Right here I'm going to combine like terms. So I'm going to have 2x to the m. When you multiply, add your exponents, your base stays the same. So x to the m plus n. Right here you have a power to a power, so you're going to multiply your exponents. If you have a negative exponent, you cannot do that. So basically your base is going to flip, and then your exponent becomes positive. Same thing with this one, your base flips, so it becomes y over x, and the z becomes positive. Next column, anything to the 0 power is 1, except when x is 0. X cannot be 0, because if 0 was x, this would be undefined. So if I come down to 26, 0 to the 0 power is undefined. Okay, back to 22, I'm going to add, so I'm going to combine like terms. Well, I can't combine like terms because they have different exponents. So that's as far as I can actually simplify that. This one is dividing, and when I divide, I subtract my exponents. And we can just cross this one out. I'm not going to put anything there at this time. And then 28, I have a negative exponent, but this time it's on the bottom. So x moves to the top, and my exponent becomes positive. Okay, so now that brings us to our actual questions. Okay, so I need to first of all get rid of my parentheses. Okay, so I need to make sure that each of those bases in there have an exponent. So I gave the -5 a 1. Now, since -5 is in parentheses, or since this whole thing is in parentheses, I'm going to keep my -5 in parentheses, and I'm going to multiply the exponents. That's going to give me -5 to the -2nd power, x to the 6th, y to the 4th, and z to the -8th. Okay, I'm going to bring down this stuff. I haven't done anything with this yet. Now, since they're all together, like smashed together with no symbols in between, that means I'm going to multiply. So when I multiply, I'm going to actually add the exponents. So that's going to give me x squared. That's really a y to the 1st. So if I combine the y's, I get y to the 5th. And I don't have any other z's, so I'm just going to bring down z to the -8th. Okay. Now I have these numbers. Well, this 10 is just 10. Well, let me just bring them both down first. Okay, so what I'm going to do now is I have to keep in mind that I have to answer with positive exponents only. And we've done this before on our basic facts from, I think it was last time. So since I have negative exponents, I need to make a fraction. And I'm going to separate all these. My positive exponents go on the top. So 10 goes on top. This -5 with the -2nd power, that's going to go to the bottom. So my -2 exponent becomes a positive. X and the y's, those stay on top. And the z has to go on the bottom, but the -8 becomes a +8. Now there's actually something I can do with this. I'm going to make that +25, because -5 times -5 is +25. And then the last thing I want to do is I can actually simplify 10/25. That's going to reduce to 2/5. Yeah. So 2x squared, y to the 5th is my numerator, and then 5z to the 8th is my denominator. So that's my final answer to 31. Okay, 33. I need to, first of all, get rid of my parentheses, which I did back on 31. So I'm going to make sure all my bases have exponents. And then I'm going to multiply my exponents. So that's going to give me 3 to the 3rd, x to the -12th, y to the +3rd, and z to the -6th. Okay, denominator, I get 9 to the -2nd, x to the -10th, y to the 6th, and z to the 8th. Now I have a division problem. So what I need to do is, first of all, I'm going to ignore this for a second and just look at my variables. I'm going to subtract my variables, or exponents, I mean, for my variables. So this is -12 minus -10, which becomes -2. Okay, then I'm going to take 3 minus 6. That's going to give me a -3. And then -6 minus 8 is -14. Well, these all have negative exponents. So those all have to go to the bottom. So x squared, y cubed, z to the 14th. Okay, 3 cubed, I'm going to leave that on the top, which is actually 27. This has a negative exponent. Since it's on the bottom, it's going to move to the top. So if I move 9 squared to the top, that's actually 81. Now, if I had something like this on the no calculator part, I would probably just leave it like that. If it was on the calculator part, then I would go ahead and multiply the 27 and the 81. So 27 times 81 using my calculator is 2,187. So that's my numerator, and then my denominator is just going to stay the same. So that's my answer to number 33. This is 33. And this one was 31. Okay, that brings us to, I believe, the last page of our notes. Okay, so no matter what, the first thing you want to do is get rid of your parentheses. This time I have a fraction in parentheses, so I have to do everything inside there first. I'm going to do this exponent last this time because I can divide first. So when I divide, I'm going to simplify my fractions. So 6/9 reduces to 2/3. And I'm going to subtract my exponents. So -5 minus 1, that's -6. 1 minus 4, that's -3. -2 minus -3 is 1. All right, now I'm going to go ahead. I'm going to get rid of my negatives at the end. I'm going to bring down that -5. So now I'm going to take each of these terms here, or I guess they're not really terms, these things, I'll call them things. I'm going to take their exponents and multiply them with the -5. So I'm going to get 2/3 to the -5th power, x to the 30th, y to the 15th, and z to the -5th. Okay, I can't have negative exponents, so x goes on the top, y goes on the top, and c goes to the bottom. Now, I'm actually going to flip this. So 3 would go on top and 2 would go on the bottom because it has a negative exponent. So 3 to the 5th would go on top and 2 to the 5th would go on the bottom. And I'm just going to leave it like that. If it was a calculator question, then I would go ahead and figure this out. Okay, 35. All right, looks like I have an addition sign. So I'm going to have to do this first and then combine like terms in the end if I can. So no matter what, the first thing you want to do is get rid of your parentheses. So I'm going to multiply my exponents. So I get 2 squared, x to the 6th, and y squared. And then this one I'm going to have x to the 12th, y to the 9th. This I don't have to do anything with yet, so I'm just going to bring that down. And then I'm going to multiply the exponents right here. So x to the 14th and y to the 7th. Okay, so again, before I can add, I have to simplify each side. So this really means the multiply if they're all smashed together like that. Which means I am going to add my exponents if they have the same base. I'm also going to change 2 squared to 4. So 4, that's going to give me x to the 18th. That's going to give me y to the 11th. Okay, over here I have a 3. This is going to give me x to the 18th. And that's going to give me y to the 11th. Okay, now I can finally add because I have like terms. All I have to do is take the 4 plus the 3, which is the 7, and then my terms are going to stay the same. So that is my final answer to 35. So in summary, all we did was add and subtracted radicals, and then we did exponent rules, and that was lesson 4.3.